Hey guys, my name is Narayan and today I'll be explaining about the two basic components we use on any electrical projects, that is a breadboard and a resistor. First, under breadboard we learn what is a breadboard and why do we use breadboard in our projects and how to make connections on a breadboard. Next, we'll go to resistors. We learn what is a resistor and how to find the resistance value from these color codes. So in real-time applications, we can just look at the resistor and get the resistance value from the color code. What is a breadboard? It is a board we use for prototyping. During a project build, we start making a basic prototype. Then if we find any modifications to the circuit to make it better or to change the components, we cannot go and desolder and change the PCB as it won't be feasible. So what is the best thing to use? A breadboard. Breadboard is a solderless device used for temporary prototyping with electronics and test circuit designs. Most electronic components in an electronic circuit can be interconnected by intersecting the LEDs or terminals into the holes. Hence, we can first make the temporary circuit on a breadboard and then later make a permanent one on a PCB. So this is what a breadboard looks like. A breadboard mainly has two parts, the grid and the power rails. The power rails are on the top and bottom of the breadboard. These are usually for positive and negative connections to the circuit, and these are where the components go in. In the grid there are two sections, each with 65 columns and 5 holes in each column. Each of these 65 columns are not connected to each other. Instead, all the holes in each column are connected. Let's see, say this hole will be connected to all the holes in its vertical column, and this hole would be connected to all these 5 holes. These two sides are not connected, so over here 5 and over here 5. If you want to connect these two, we make a simple connection like this. Next, we move on to this gap. This gap is also known as the IC gap. It's the perfect width to fit an IC. For example, let's take a look at this IC. Say we want to connect this IC to our breadboard. So we bring the IC to the IC gap and align the holes and we insert it into the breadboard. So each of these legs of the IC would be connected to these 4 in each column. So this IC has 14 legs on either side and these 14 legs are connected to these 14 columns. So now let's move on to the power rails. So each breadboard has two pairs of power rails, one on the top and one on the bottom. Generally, the power rail next to the blue line is allotted for negative and next to the red line is for positive. In each power lines, there are 10 segments with 5 holes each. First 5 segments are connected and the next 5 are connected. Over here, we have a gap separating these two. So right now, a connection over here would just connect to these 25 holes and over here to these 25 holes. So what we do generally to maximize the use of this is, we have a small connection in the middle which bridges these two sides. So now if we connect this and this to either sides of batteries, that is a negative over here and positive over here, this whole row would be connected to the negative and this whole row would be connected to the positive. Same thing applies over here. Now let's move on to resistors. Most of you guys must already know what a resistor is. For the people who don't, it's an electrical component which limits the amount of current passed through it. Now let us see how to decode this color coding of the resistor to find the resistance value. We can see there are 3 bands together and one band a little bit far apart. How this works is, each band is of different color. Each color represents a different digit. So black represents 0, brown represents 1, red 2 and so on. So how do we determine the resistance from this color code? From the 3 different bands, first band would correspond to the first digit. Second band would correspond to the second digit. And the third band is called a multiplier. That is, it corresponds to the 10th power to which we multiply this. So in this example, over here there are 2 red bands and 1 brown, and after a far distance the gold band. So now the first band is red and red corresponds to 2. Next one is also red, so we get 22. Now the multiplier. The multiplier is brown in color. Brown corresponds to 1. So we get the net resistance as 22 into 10 raised to 1. It should be equal to 220 ohms. We use this table in order to determine the digit which each color represented. So now let us look at a shortcut to by heart all this. We can see black, brown, red, orange, yellow, green, blue, violet, grey is in an order of 0 to 9. That is BB Roy of Great Britain had a very good looking wife with gold and silver ornaments. So once you by heart this, BB Roy of Great Britain had a very good looking wife with gold silver ornaments. We can remember the digits each color represents. Also keep the order in mind, that is BB Roy of Great Britain. There are 3 B's already. So black, brown, blue. That is the order in which this will go. So let us make a basic connection using breadboard and resistors and a battery and LED. We can only pass a maximum of 20 milliamps through an LED. If we pass more than 20 milliamps, the LED would fry and won't work again. So right now, I have a small setup on a breadboard. I have connected a 10k ohm resistor to these two rails of the breadboard and the positive to this rail and negative to this rail of the breadboard. Now let's take an LED. Each LED has a longer and a shorter lead. So the longer one will connect to the positive and the shorter one to the resistor. So once the connection is made, let's take a jumper cable. A jumper cable is a custom wire which we use for connecting different holes in a breadboard. So now we connect one end of the jumper wire to the resistor and the other to the negative end of the battery. So you can see the LED glows. That's it for this video. Please consider like, share and subscribing to our channel for more educational content.